Welcome everybody. We're moving from chapter 11 to chapter 12 to do a few lessons there. This one is simplifying rational expressions. You'll be able to simplify rational expressions, and another objective, of course, would be you'll be able to define what is a rational expression. Well, a rational expression can be written in the form of a polynomial on top of a polynomial. So a rational expression is basically a polynomial on top of a polynomial. Rational expressions are in simplest form when the numerator and denominator have no common factors except one. So basically, like a reduced fraction, same kind of thing. So what we're going to do is try and simplify this. The way we're going to simplify this is by trying to factor each of the binomials. So on the top one, I could factor that and say 3 and then x plus 3. So I divided the top by 3. Now, if I look at what I have in the denominator, I see that these two match. So I can cross them both off. They're 1. And all that's really left is a 3. So now I've simplified this rational expression. Let's try this again. Now what I'm going to do is same thing, I'm going to try and factor the top. Well, I know I can take a 2 out. So I'm going to divide the top by 2, and what's left is 3 minus x. Now, if I look down here, I have x minus 3. So I want to talk to you for a second. While you do these problems, you might encounter this, where they're almost the same, except the x is negative and the x is positive here, and the 3 is positive and the 3 is negative. So what we're going to do is we're going to take a negative 1 out of this top binomial. So if I do that, here's what happens. The negative 1 comes over here and multiplies to the 2. So now I have negative 2, and then what happens is my 3 becomes negative and my x becomes positive. And if I look down here, and I'm going to rewrite my bottom binomial, if I look here, my 3 is negative, so I wrote it there, my x is positive. Now they match. Now they match. So I cross them both off, and my answer is negative 2. Alright, some more to try. So it's just basically factoring. So what I'm going to do is factor the top and see if I can reduce. If you notice, I took an x out of the top binomial, and now I have 3 x's here and 1 x here, so I'm going to subtract 1 here and make this 2 x's because I can cancel one of them. Here's what I'm left with. I'm left with the 4x plus 1, and then I'm left with x squared because one of these x's right here reduced my 3 to a 2. I cannot do anything else. I'm done. I can't factor anything. So let's move on to the next one. Here we have trinomials, and if you remember factoring trinomials, we're going to factor these trinomials. Okay, so hopefully you remember factoring. On this top one, 6 times negative 12 is negative 72, but it needs to add to negative 1, and then you do tic-tac-toe or Dave Jones method. Here, 8 times negative 3 is negative 24, x squared, and it has to add to negative 10x. So I did all that, and I'm going to show you what I got. So after I factor both of these, here's what I ended up with. If you notice, these two do match. So because they match, I can cross them off and make them ones. Here's my final answer. 3x plus 4 over 4x plus 1, and now it is simplified. Okay, let's factor the top, and we'll factor the bottom. On the top, I divided both terms by 4, and I ended up with 4 times parentheses x minus 5. On the bottom, I'm going to say to myself, what times what is 20 but adds to negative 9? And it is, of course, negative 4 times negative 5 is 20, but if you add them together, you get negative 9. And I look and I see these match. That's great. They match, so I can reduce. What's left? 4 on top of x minus 4. I cannot do anything else. I'm done. This slide is called Recognizing Opposite Factors. We did it a little bit on my second example. It's basically where you almost have matches, but one of them has to be divided by a negative, so it changes a little bit. So let's try and factor the top and factor the bottom. On the top, I divided each term by 3 and ended up with this. On the bottom, I have difference of squares, so I'll show you that. I end up with the square root of 81 is 9, and the square root of x squared is x. And remember, one's positive and one's negative, and then it'll work. No middle term, and you get a negative here. So if I look at these two binomials, I'm so close. So I see the x is positive here, but it's negative here, and the 9's negative here, but positive here. So if that happens, what you can do is take out a negative 1. It doesn't matter which one you divide by negative 1. So I'm going to divide this by negative 1. And when I do that, the negative 1 will multiply to the 3 and look like this. And what's left here, the 9 will become positive, and I'm going to write it first. And the x would become negative, and I'll write it there. Now, the denominator stayed the same, so 9 plus x and 9 minus x. Well, sure enough, if I look right here, now these two match perfectly, so I cross them off. Here's my answer. My answer is right there. So I was able to reduce. Okay, let's factor this. The top you can divide by x, and the bottom you need to do difference of squares. On the top, I did take an x out, so now I ended up with x plus 8 inside. And here, the square root of x is x, or x squared is x. The square root of 64 is 8. 1 is minus, 1 is plus. Hey, they match. That's great. I can cross them off. My answer is x on top of x minus 8. I'm good to go. It worked. One more. Can't factor the top. I can factor the bottom because I have a square minus a square. So let's do difference of squares. On the bottom, I ended up with 6 plus x and 6 minus x. And I look and, so close. But look again, look closely. X is positive, here it's negative. 6 is negative, 6 is positive. So let's take that negative 1 out, and we're going to divide the top by negative 1, and it will change the signs. Okay, so I divided the top by negative 1, so the x became negative. I wrote it second. The negative 6 became positive. Here's very important, that negative 1 just can't go anywhere or disappear. You have to keep it. So the negative 1 is out here on the side now. Now these two match perfectly. So I can cross them both off. And my final answer is on the left here. It's negative 1 over 6 plus x. So here we have simplified this rational expression. Here are your practice problems. Only 3 of them. Please show work and bring any questions you have to class next time we meet. Take care.